Hi guys, welcome back to my channel. This is Grishma MS, currently studying in Sri Venkateswara College of Engineering. Today's my subject is about mathematics for computer science and my topic is about standard error of estimate. So let's start the video. Introduction to standard error of estimate. The standard error of estimate is a measure of the accuracy of predictions made by a regression model. It quantifies the average distance between the observed value and the predicted value from regression line. It is also known as the root mean square error or a residual standard error. So let's see the next slide. Before going to the next slide, you can see the picture that how it goes. Raise the standard error regressions lines according to the graph. Formula for standard error of estimate. The formula for calculating the standard error of estimate is, so the standard error is equal to S divided by root n is the formula for it. Y represents the observed value and Y cap represents the predicted value and n is the number of data point. The formula divides the sum of squared difference between observed and predicted values by degrees of freedom. Interpretations of standard error of estimate. The standard error of estimate provides a measure of a typical distance between the actual and predicted values. A lower standard error of an estimate indicates a better fit of a regression model to the data. It helps to evaluate the precision of the prediction made by the regression model. Importance of standard error of estimate. The standard error of estimate helps assess the reliability and accuracy of the regression model. It enables the comparison of the different models to determine the best fitting model for a given date set. It provides insights into the variability and dispersion of a data points around the regression line. Relationship with r squared and standard error of an estimate are inversely related. A higher r squared indicates a lower standard error of estimate, suggesting a better fit of the model. R squared measures the proportion of various sum in the department variable explained by the independent. So let's move to the next slide. Standard error estimate versus standard deviation. The standard error of estimate measures the dispersion of an observed value around the regression line. Standard deviation measures the dispersion of an individual data pointers around the mean. The standard error of an estimator it depends on the regression model while standard deviation is not. Assumption for standard error of estimate. The standard error of estimate assumes that the errors are normally distributed. It assumes that the errors have contest variance and are independent of each other. Violation of these assumptions may affect the accuracy and the reliability of the standard error of estimate. Calculation example. Consider a simple linear regression model with 10 data points. Calculate the predicted values for each date points using the regression equation, calculating the difference between the observed predicted value and square them. So as the example is said, we can see in the image what we have to use in the formula. So interpreting the standard error of estimate. A standard error of estimate for phi indicates that one average the predicted values can deviate from observed value by 5 units. The standard error of estimate helps to evaluate the precision of the regression model prediction. It is used to contract prediction intervals around predicted values. Confidence interval for predictions. The standard error of an estimate is used to construct confidence intervals around the predicted values. A wider confidence intervals indicates more uncertainty in the predictions. The confidence interval provides a range within which the true value are likely to fall. Limitations of standard error of estimate. The standard error of estimate assumes that the regression model is the correct representations of the relationship between the variables. It does not provide information about the direction of magnitude of the error. It does not capture potential outliers or inflation points that may affect the overall fit the model. Importance of residual analysis. Residual analysis helps invalidate the assumptions of the standard error of estimate. It involves examining the residuals of a pattern or a diversion for assumptions. Residual plots can identify outliers, non-linearity, heteroscedasticity, and other issues that may affect the accuracy of the estimates. Interpreting the residuals. If the residuals are randomly scattered around zero with no specific pattern, it suggests a good fit of the model. No random pattern such as U-shape or a funnel shape indicates potential problem with the model. Outliers in the residual may indicate extreme observations or inflation points that need further investigation. Standard error of an estimate is multi-regressions. The standard error of estimate can extend the multiple regression model. It measures the overall accuracy of the prediction made by the multiple regression model. It quantifies the average distance between the observed values and the prediction value of the regression surface. Adjusted R squared. Adjusted R-squared is a modified version of R-squared that accounts for number of predictions in the model. It penalizes the inclusions of unnecessary predictors, preventing overfitting. Adjusted R-squared is helpful in comparing model with different numbers of predictors. Limitation of standard error of estimate in multiple regressions. The standard error of estimate in multiple regression assumes linearity constant variations in independent of errors. Violation of these assumptions may lead to the underestimation or overestimation of the standard error of estimate. It is important to access the residual conducted diagnostic test to ensure the validity of multiple regression models. Applications example. Standard error estimate are widely used in fields such as economics, social science, finance, and engineering. It helps to evaluate the accuracy of an economic forecast and stock price prediction and demand forecasting models. It is also used to quality control and the process improvement to access and precision of regression-based model. So the conclusion of this topic is the standard error of estimate is a crucial statistic regression analysis. It quantifies the averages distance between the observed predicted values, and it helps in the access of accuracy, relativity, and precision in the regression models. I hope that you have liked this video. Please like, share, and subscribe my channel. Thank you.